So there's operations that yield an equivalent. Okay, so here's this is the, I'll talk about this in a little bit, but this is like really important for this section. Let's go down to let's go start on number 1 here. If a system of linear equations has infinitely many solutions, then the system is called dependent. And I think that's just the notation for this book. Or maybe other people use that notation, but that makes sense. If a system of linear equations has no solution, then it's called inconsistent. Okay, so dependent means that there's infinitely many solutions. Inconsistent means that there's no solution. So those are certainly possibilities. The other possibility is where you have exactly one solution. Okay, so number 2, so what we're going to be doing in this section is we're going to be taking these systems of equations and we're going to write it in a matrix, which basically preserves all the information that we need to solve the system. So the augmented matrix, what happens is you just place the coefficients of the x, y's, and z's in these boxes, and then the coefficient on the right side you place over here. So like this top equation right here, x plus y minus z equals 1, that would go into the matrix like this. So that means x plus y minus z equals 1. Okay, and then this second equation we're going as x, and then there's no y's, so we just put a 0 there. And then there's a 4z, so that's 4, and then a -2 on the right side, so you put a -2 there. Okay, and then the last equation, there's no x, so you put a 0 there. You put a 4 for the y and a -1 for the z and a 2 for the right-hand side. Okay, these arrows right here allow you to change the size of the matrix if you need to. They usually put it right to the sides that you need though, so you usually don't have to mess with that. But those are there just in case. Okay, so that's number 1. So so this right here, number 2, represents the first step in the overall strategy, which is translate the equation into an augmented matrix. So you have an equation like that, you'll translate it into a matrix like this. Okay, the next thing you're going to do is you're going to do operations to get equivalent matrices until you have a triangular matrix. So these operations are the corresponding operations we talked about in the previous section, but applied to matrices. They do the exact same thing, but with when the system is in matrix form. Okay, and until you get a triangular matrix, and then you use technology to calculate, or you can use technology to calculate reduced to echelon form. We'll get to that later. Then you translate it back into system of equations and solve it. Okay, that's the overall strategy. So we just did the first part, which is translating it into the system. And so you do the operations, and this one right here, number 3, represents what you do after you do the operations. So after you do the operations, then you translate it back into a system of equations. So this first row of the matrix would translate back to x, and there's no y, so there's 0y minus z equals 4. And then the second one would translate back to y plus 2z equals 6. And then this last one would just be, they're all zeros, so it's just 0 equals 0. Okay, the leading variables would be these two right here. So in this first row, when you translate it back, you get the x. So the x is leading this row, or leading this equation. And then here, the y is leading this equation. So x and y. Okay, and for this particular system. Okay, so part B is the system inconsistent or dependent? okay, so what's going to happen? It's probably best if we just go ahead and when you have it in this, when you get your matrix down to here and you translate it back, in this particular case, what you want to do is solve for the leading variables and solve each equation for the leading variables, okay? So taking this z over here, you get x equals z plus 4, and then taking the 2z over, you get y equals negative 2z plus 6. Okay, and then what you do is you set z equal to t. And when you do that, then this z here gets replaced with a t. So x equals t plus 4. And that's not very good for. Okay, and then y is negative 2t plus 6. Okay, so you go ahead and put this stuff in here, t plus 4, negative 2t plus 6, and t. So what happened is, for every value of t, it's a different solution. So that means it's dependent. Okay, and since there are solutions, that it's not inconsistent, it's consistent. Okay, great. So okay. So like I said, part 3, this represents. If I go back to the first page, this represents this part of the strategy. Translate back to a system of equations and solve. Okay, so you get reduced to echelon form, or you put it in a triangular matrix and translate it back to a system of equations and solve it. And we get some more practice with that with number 4. Okay, so again, we're going to translate it back into the equation. So the top line is x equals 4. Second line is y equals 1. Because there's no x there, there's no y, x or y here. So it starts with z, and z equals 2 is the last one. So it's just 4, 1, and 2 is what we end up with, is the answers right there. Okay, for part B, when we translate it back, we get x plus z equals 4. And then the second one is y plus z equals 1. So then you solve each of those for the leading variable. Like that. Except you write your z a little bit better than I did. Okay. And then you set z equal to t. Okay, so that's t is going to go in there, which means that when you do that, then x is negative t plus 4, and y is negative t plus 1. Okay, and then part C. The first equation gives you x equals 4. The second one gives you y equals 1. The bottom equation gives you 0 equals 2, though. And that's that equation is not, you can never make that true. So that gives you a lot of trouble. That means that there's no solution. But okay, so or inconsistent. It doesn't really matter what those are. You have to satisfy all of the equations. Okay, so even though we got a value x equals 4, we don't just put a 4 there. That's not going to work. So you just put inconsistent there, and that's how you spell it right there. So, or you can find how you spell it better. Okay. Number 5 is the dimension of the matrix. So the dimension, the dimension is going to be the number of rows cross the number of columns. Oops. Okay. So with this, the rows are these. This is the top row, this is the second row, the third row. So that means there's 3 rows. So number of rows, 3. The number of columns are, the columns are these. So there's 2 columns, 3 by 2. Okay. Here, there's only 1 row. That's 1. But there's 3 columns by 3. Okay. So those are going to be the answers to 5 and 6. And then, okay, now 7 is excuse me. 7 is doing row operations, and these are similar to the operations we do to the equations to get equivalent systems. Okay, so add 2 times row 1 to row 2. So we're adding a multiple of row 1 to row 2. That means that row 1 does not change. So I'm going to go ahead and write that down. Row 3 doesn't change either. It doesn't say anything about doing anything to row 3. Only row 2 is going to change. So we're going to add 2 times row 1 to row 2. Okay, so 2 times -5 is -10, plus 10 is 0. So this time you do have to put a 0, even though you can't just leave it blank. 2 times 4 is 8, minus 2 is 6. So you put a 6 there. 2 times -2 is -4, plus 3, plus 1 is -3. 2 times 2 is 4, minus 20 is -16. Okay, so this is the matrix that you should get when you do this. Like I said, the top row and the third row don't change at all when you do this operation. So once again, what we're trying to do here is, well, you try to get a 1 right here. So probably if we were actually trying to solve this, if this came from a system that we're trying to solve, then we would probably swap the first and the third row so we can, and then multiply by -1 so we can get a 1 in this position. Okay, and then get zeros down here. So getting a 0 there was great. That was good. Okay, and here's another one. The matrix is in row echelon form, and so we're supposed to write this system of equations for which the given matrix is the augmented matrix. Okay, so let's go ahead and do that one. So this top row is x plus y minus 3z. That's what these 3 numbers count for, and it equals 15. The 15 is over here. Okay, the second row, there's no x, so it's just y minus 3z. And then the bottom run, there's no x or y, so it's just, this is just z equals -3. So you have 15, 13, and -3 over here on the right-hand side. So here's our system of equations. And back substitution, so we know right off the bat that z is -3. So maybe we can just even stick a -3 right there in the z position. Okay, and then this one is y minus 3z equals 13. We'll plug that -3 into here. That gives you y plus 9 equals 13. So subtracting 9 from both sides, you have y equals 4. So that's going to be a 4 right there. Now we just need to find x. And so we take this top equation, so that and that, we're going to plug it in for x. So x gets replaced with a, oh wait, x is what we're trying to find. Okay, this y gets replaced with a 4. So it's x plus 4 minus 3. And then this z gets replaced with a negative 3. Okay, so that 4 goes here, and the negative 3 goes there. And that's equal to 15. Okay, so we have x plus 4 plus 9 equals 15, or x plus 13 equals 15. Subtract 13 from both sides, we have x is 2. So that should be a 2 right there. Okay, so that should work right there. Okay, number 9 is to set us loose finally. After 8 exercises of fooling around, now we actually get to do what we set out, what we're meant to do, which is to solve a system of equations using these techniques. Okay, so these are the operations that we can do that yield an equivalent matrix. And this is the overall strategy. Let's go ahead and go through this exercise. So first step is to translate the equation into an augmented matrix. Okay, so this system, the first line, you got x, 1x minus 2y plus 1z equals 0. That's going to be for this first row. The second row, you got no x's, so that's 0. You got a 1y, so that's 1. You got 2z, so that's 2. And a 20. And then the third one is 1, 1, 3, 36. Okay, so great. We have a 1 here, so that's great. That's 0, so that's even better. This is a 1 there, so let's get rid of that 1. We'll use the top row to do it. So I'm going to multiply the top row by -1 and add it to the bottom row. Okay, so -1 times 1 is -1, plus 1 is 0. So that's going to be a 0 there. -1 times -2 is 2, plus 1 is 3, so that's going to be a 3. -1 times 1 is -1, plus 3 is 2, so that'll be a 2. And then -1 times 0 is 0, plus 36, that's just going to remain being a 36, like that. Okay, now, great, so we have zeros here and here. The next thing was to try to get a 1 right here, which represents trying to get a y right there, which we have, so that's great. Now we need a 0 here before we can do the back substitution. So let's leave the top 2 rows the same. We'll use the second row to eliminate this 3. Yeah. Okay, so we'll multiply this row by -3 and we'll add it to the bottom row. Okay, so -3 times 0 is 0, plus 0 is 0, so that's going to be 0. -3 times 1 is -3 plus 3, that's 0. -3 times 2 is -6, plus 2 is -4. And -3 times 20 is -60, plus 36 is, whoa. Is that 24? negative 24. Okay, so now that we have a triangular matrix, which means that you got zeros here, and so you've got this right here is called the main diagonal. When you start from the bottom, when you start from the top left, and you go down 1 and over 1, and then you go down 1 and over 1, those three numbers right there, the 1, 1, and 4, are on the main diagonal. And these zeros are everything that's below the main diagonal is just these three entries that are all zeros. So having all these being zeros, that's what triangular means. Triangular matrix. So we have a triangular matrix because we have zeros here in these three slots that are below the main diagonal. So we'll go ahead and translate it back into system of equations and solve it. Okay, so we translate it back. So x minus 2y plus z equals 0. And then the second equation is y plus 2z equals 20. And the bottom one is negative 4z equals negative 24. Now this bottom equation, we start here. Dividing both sides by negative 4, we get z equals 6. Okay, and then what we're going to do is plug that 6 into this equation. So plug that 6 into here. We have y plus 2 times 6 equals 20. So y plus 12 is 20. That means y is 8 by subtracting 12 from both sides here. So y is 8. Then we plug both of these into the top equation. So we plug this y in here. So that y is 8. And this z is 6. And we have everything equals 0. So we have x minus 16 plus 6 equals 0. So x minus 10 equals 0. So x is 10. And so our answer is going to be 10. We put the x first, then the y, which is 8, not just the letter y, but the number 8, and then 6. 10, 8, 6, and that would be the answer for number 9. Any concerns with this? Any questions? So that's the basic way to do it. Let's do I'm going to show you another way. It's important to know this way because sometimes technology can't do it. But with number 10, I'll show you how you can do this with Geogebra. Okay. So you still have to do the first part where you translate it into a matrix, into an augmented matrix. Okay, so this first equation becomes 1, 1, 1, 7. More space. Okay, the second equation becomes negative 1, 2y, 3z equals 49. The third equation, okay, so now here I don't have them quite lined up like Webassign does, but this is 2x right here, negative 1y. There's no z, so that should be a 0 there, and then a negative 26 on the right-hand side. Okay, so I have this matrix here, and I'm going to plug it into Geogebra. This right here is what you use to get it into Geogebra, and also you want to use the CAS calculator. But that's the notation for doing it. So remember that notation. And then this is the command that you want to do next. After you input the matrix, this is the command that you want to put: reduced row echelon form of A. Okay, so I'm gonna go out to I'm gonna switch to Webassign, to Geogebra, and show you how this works. Okay, so here Okay, so here I have, make this smaller. Okay, so here I have Geogebra, and you want to choose the CAS calculator right here. So go to that. Okay, now the matrix that I put in, you want to say A equals, and then to put the matrix in, you start with 2 curly braces like that. You put the first row in with separated by comma. So 1, 1, 1, 7 was the first row. And then I close that off, and then I put another comma and then another curly braces. And the second row, so that was -1, 2, 3, 49. I close that off, another comma, brace, curly braces, 2, -1, oops, -1, 0, -26. Okay, hit enter. Okay, so that was, so then when I hit enter, it shows it as a matrix like that. Okay. And you can double check if there's any of these that are wrong, you can click on the matrix and change them. You can go through and edit this if you want. Okay. But everything looks okay. So the next thing you do is you start typing out reduced. Once you get to the D, it kind of just appears there. See how it just kind of appears there? And you just hit enter. And it has this word matrix highlighted. If you call the matrix A, then you just put an A right there and hit enter. Okay. And so this right here, if you take this matrix, reduced row echelon is this form right here. So we'll go back. Let's go back to. Okay, so remember this. This is what it looks like. Okay, so we go back to here and doing the operations. Okay, so we'll just say this is Geogebra operations, reduced row echelon, blah, 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 form. Okay, and then boom, it gives you this matrix here, 1, 0, 0, -9. That was the first row of the matrix from Geogebra. And then 0, 1, 0, 8, and then 0, 0, 1, 8. Okay, so that was the matrix. And so then the next step is you translate back to a system of equations. The top row is x equals -9. The second row is y equals 8, and the third row is z equals 8. And then you just put the answer in, -9, 8, 8, and you're done. Okay, so let's do another one. Number 11. So again, here, we're going to put that in as we're going to translate it to an equation, into a matrix. So -2, 6, -2, -18 for the first row. The second row is 1, 3, 2, 17. Third row is going to be -1, 3, 2, 15. Okay. Then we're going to use Geogebra. Again, I'll go over and put that in there. And since I already have A, I'm going to make this one B, and curly, and then put the matrix in. And then if you don't get the right number, okay, then double check right here. If you don't get, like, if you don't get the right number of, like, let's say you, instead of for row 1, you put, or for, let's say for row 1, you put 4 elements, and then for row 2, you only put 3 elements, then it's not going to show up as a matrix like this. And so you'll have to go back and edit what you have until it does show up as a matrix, okay? And then once again, as soon as you type that D, it just gives you that, so press enter and then put the B in. And that's going to be your, okay, so here, this is the reduced row echelon for this matrix, for the matrix that corresponds to number 11. Okay, so let's, okay, so I'm going to go back to the other document, and we'll go ahead and write this matrix out over there. So we basically just let Geogebra do the hard stuff. And we come up with this matrix here. Okay. If this bottom row is all zeros, then we're still good. But if the bottom row has 0, 0, 0, 1, so it's all 0, and then that would correspond with the equation 0 equals 1. And now whenever you see that, that means inconsistent. Okay, but this one's not that case. So when we translate back, the top equation is x minus 3y equals 1. The second equation is z equals 8. Okay, so here we have this variable y. And what you want to do, and they kind of give you a hint as to what's happening here. You're going to set y equal to t is the key right here. So if you look at the instructions, sometimes they give you little hints and stuff on how to solve the problem. So if you take this first equation and solve for x, you get x equals 3y plus 1. But making this substitution here, you get x equals 3t plus 1. Okay, so you're gonna, this is dependent because you're gonna have infinitely many solutions. And the x one, let's see here. There's not enough space for me to do that here, so I'll do it right here. So the x is 3t plus 1, y is t from here, and then z is 8. So just an 8 from there. Okay, that's going to be your answer for number 11. Okay, number 12. So let's go ahead and put it into, here we have R, S, and T. So we just kind of keep, so R is going to be the first column, S is going to be the second column, T is going to be the third column. So the first equation, 3, 2, negative 3, 18. Dang, I'm always making these too small. The second equation, 1, negative 1, negative 1, negative 9. And the third equation, 1, 4, negative 1, 36. Okay, and then I'm going to use Geogebra again. And I'll make this one C. Okay, and once you get to here, it's really important to double check that this is the matrix that you wanted. Because if there's just one entry that's wrong, then the whole thing, you're probably going to get the whole problem wrong. Put a C in there. Okay, so good. That's what this one reduces down to. let's go ahead and put that in the document. So this is reduced down to 1, 0, negative 1, 0, 0, 1, 0, 9, and then 0, 0, 0, 0. Okay, so the top, so you translate it back to a system of equations. The top one is x minus z equals 0. And the second one is y equals 9. And the bottom one is 0 equals 0. So when you see 0 equals 0, just throw that out and disregard it and only work with the other ones, okay? So this is what, x equals z and y equals 9. So you know what 9, you know y is 9 already. X is z, so in that case, we're going to set, whoa, the Webassign, I think they messed up. It should say z equals t, and that means x is going to be t also. So that gives you x is t, y is 9, and z is t. Okay, so that's going to be the solution, and it is dependent because there's infinitely many solutions. So both of those. Okay, let's look at number 13. So here, -4, -1, 36, 24 for the first row, 1, -2, 9, and 3 for the second row, and -2, 1, 6, and 6 for the third row. Okay, let's see this is number 13. We're a little bit low on time, so I'm just going to tell you what happens. So if you do Geogebra, that's going to give you 1, 0, -7, -5, 0, 1, -8, -4, and then 0, and then all zeros. Okay, so then translating it back, you get x minus 7z equals -5, and then for the top one, and then the second one is y minus 8z equals -4. And then the bottom one is just 0 equals 0, so I just disregard that. This is interesting. I didn't choose a question that's inconsistent. I'll just say that at the end though. Okay, so when you get this kind of thing where you have these variables right here, that means your z is going to be independent, but the x and the y are going to be dependent variables on the z. So you take each of these, like to take the first equation, just solve for x. And take the second equation and solve for y by taking this 8z to the other side. So add 8z to both sides. And then you set the independent variable equal to t. So z equals t. And then after you do this, then x becomes 7t minus 5, and y becomes 8t minus 4. Okay, so then your answer, the x is 7t minus 5, y is 8t minus 4, and z is just plain old t. And that's your solution right there. Okay, let's do number 14. Okay, here you have x, y, z, and W. So you have 4 variables. Okay, so this one, the top equation becomes 1, 1, 2, -1, -8. Wow, lots of terms. Okay. The second equation, there's no x, so that's a 0. The y thing has a 3, the z has a 1, and w is 2, and then the other side is 8. And then for the third one, you have 1, x is 1, y is 1, z is gone. There's no z, so that's a 0. And then w is 3, and then the other side is 8. And then the bottom one is -3. There's no y, so you got to put 0 there. Z is 1, and then 2w, and then a 20. Okay, so we have that matrix there. And well, I didn't save myself very much space. Okay, so let's just do this in GeoGebra. So what do we have? 1, 1, 2, -1, -8, and then 0, 3, 1, 2, 8. 0, 3, 8. And you got to put commas in here. If you don't put commas, then you're also going to be messed up. Make sure that's what we want. Then we want reduced. Okay, now I'm off this page, but I know that if I hit enter, it's just going to give me that. So, okay, so this goes down to this matrix here. Okay. So I'm going to go ahead and input that into the other document. There's that 1, 0, 0, 0, -4. This is the X column. This one is in the Y column. This one is in the Z column. And this one is in the W column. So when that translates back, the top one becomes X equals -4. The second one becomes Y equals 0. Third one becomes Z equals 0. The fourth row becomes W equals 4. And so the answer is going to be -4 for the X, Y and Z are 0, and then 4 for the W. Okay, so that's going to be the answer right there. Okay, then number 5. Okay, so number 5 illustrates some problems that you cut. It illustrates something else that could happen when you're doing this. So let me do this. Let me show you what happens when you do this with Webassign. With GeoGebra. So this is X, Y. There's a Z and X, Y, Z, W. So 4 variables. For the first equation, the Z is not there, so you put a 0 in the Z spot and a 1 in the W spot, and then 0 for the right-hand side. The second one, 3x, there's no y. So you have, and then there's a -1 on the z, 2 on the w, 0. The third equation, 1, -4, 1, 2, 0, like that. Okay. So now we're going to do GeoGebra. We'll put that matrix in GeoGebra. So I'm going to call that E. Right there. And then we're going to do a reduced from echelon of E. Okay, this is where GeoGebra kind of falls apart. I don't know. I've tried to figure out how to make it give fractions. Okay, so you have this negative 0.33333, and then you have this 0.6667 on the end, and then these. So you got these four terms that are really weird. They're not exact. They're decimal. They're decimal approximations. Okay. And so that's not acceptable. If you try to put that in Webassign, that's gonna complain and not let you do that. So you have to figure out what the fractions are, okay? And this one is not that hard because you know this is negative 1/3, this is 2/3, this is negative 1/3, this is also negative 1/3. So that's what those are. So that's not so bad to do. But in other cases, it might not be so easy to figure out, but you're gonna have to figure that out. So that means that if you have something like this, Geogebra gives you something like this, then, and you can't figure out what these numbers are, then you're gonna have to just do it by hand, okay? But that shouldn't happen that often. Okay, so what happened? Geogebra gave us 1, 0, and then it gave us this negative 0.333, a bunch of 3s, right? And then it gave us 0.66, a bunch of 6s followed by a 7, and then it gave us a 0. Okay. And then the same thing here. And then the bottom row was all 0s. So thank goodness there was nothing weird on the bottom row. Okay, so what you're going to do is you're going to use this matrix instead. 1, 0, negative 1/3, 2/3, 0, 0, 1, negative 1/3, negative 1/3, 0. You can use that one instead. And the bottom row is all 0s, so we can just throw it out. If it was if these were all 0s and then this was a 1, then it would just be inconsistent and we'd be done. Okay, so now we translate these back into the corresponding equations. So the top one is x minus 1/3 z plus 2/3 w equals 0. And then the second one is y minus 1/3 z minus 1/3 w equals 0. Okay. So here we have two independent variables, which are z and the w. So set z equal to s. Okay, the instructions say set z equals s and w equals t. Okay, and then so then what happens is with these substitutions, x is going to be negative 1/3 s plus 2/3 t, and then y is going to be negative 1/3 s minus 1/3 t. Okay, and then so then the solution, the x goes first, so that's negative 1/3 s plus 2/3 t, and then comma, the y one, that'll be wait, what am I doing? I totally messed up. Okay, so hold on a second. I made a mistake. This goes to the other side, it becomes plus, and that becomes a minus right there. Let me just fix those. That's going to be positive 1/3. This is going to be minus 2/3. And this comes over here, it's plus s plus 1/3. So that becomes, let me fix everything here. Just like that. So 1/3 s minus 2/3 t. And then the y is 1/3 s plus 1/3 t. And then the third position is z, which is s. And the fourth position is W, which is T. Okay, so that's it.